March 11, 1982. Raymond Kellerman stood at the edge of his wheat field in Sheridan County, Kansas, and watched $37,000 worth of topsoil wash into the creek below his property. The storm had dropped 2.4 inches of rain in 40 minutes. His conventional till system, the one recommended by the Soil Conservation Service, had failed completely. The gullies measured 14 inches deep in places. Kellerman had farmed that section for 19 years. He lost it to the bank 11 months later. What stopped the erosion on farms across the Great Plains was not a government program or a new chemical treatment. It was 4 inches of dead plant material left on the surface. That measurement, 4 inches, took federal scientists 3 decades to identify. Farmers figured it out in 18 months. Before we go further, if you want to understand how something as simple as measuring crop residue depth solved a crisis that cost the federal government $2.3 billion in emergency programs between 1975 and 1985, hit subscribe. These stories disappear unless someone documents them. The crisis began with a solution to a different problem. Between 1972 and 1974, global grain prices doubled. Wheat went from $1.63 per bushel to $4.09. The Nixon administration, facing domestic food inflation and strategic export opportunities with the Soviet Union, needed maximum production from American farms. Secretary of Agriculture Earl Butz gave the directive in June of 1973. Plant fence row to fence row. Use every available acre. The Soil Conservation Service, established in 1935 specifically to prevent another Dust Bowl, found itself promoting production practices its own founding documents warned against. The practice was moldboard plowing. Turn the entire field, bury all residue, create a clean seedbed with maximum soil to seed contact. The logic was straightforward. More seed germination meant higher yields. Higher yields meant meeting export contracts and paying down equipment loans that had tripled in size as farmers bought larger tractors to handle the increased acreage. International Harvester sold 14,000 tractors over 100 horsepower in 1973 alone. John Deere moved 18,000 units. Every one of those machines was designed to pull a moldboard plow through heavy clay soils at depths exceeding 12 inches. What the equipment dealers did not mention, and what the Soil Conservation Service knew but did not emphasize during the production push, was that moldboard plowing removed the one thing that held soil in place when it rained: surface residue, the stems and leaves and root crowns left after harvest. In natural prairie systems, that residue layer measured between 6 and 9 inches deep in most years. Under conventional tillage, it measured 0. The soil sat bare from October through April in winter wheat country, 6 months of exposure to wind and rain with nothing anchoring the surface particles. The first major loss event happened in April of 1975. A storm system moved through eastern Colorado and dropped 3 inches of rain in 2 hours across Yuma County. Harold Sandberg lost 22 acres of topsoil off a field he had just planted to corn. The erosion cut gullies deep enough that his planter could not cross them on the second pass. Sandberg told the local extension agent that he had farmed that ground since 1951 and had never seen anything move that much soil that fast. The county soil survey, published in 1967, rated that field as having moderate erosion potential under conventional management. The rating system did not account for total residue removal combined with high-intensity rainfall. Sandberg replanted at his own expense, $4,200. The field yielded 31 bushels per acre that fall instead of the projected 120. He broke even on seed cost and lost money on every other input. The pattern repeated across the plains. September 1976, Ellis County, Kansas. Thomas Erdman watched his Milo field wash into the road after a 2.1-inch rain. June 1977, Custer County, Nebraska. An entire quarter section owned by the Hoffman family lost an average of 4 inches of topsoil in a single storm. The county extension agent measured the deposit in the drainage ditch at the field edge. 14 inches deep, 6 feet wide, running for 300 yards. The soil survey estimated that field had 9 inches of topsoil remaining before hitting the clay hardpan. After one rain event, it had 5. The Soil Conservation Service responded the way institutions respond. They formed a committee. In August of 1977, the agency commissioned a study through the University of Nebraska to document erosion rates under conventional tillage and propose management solutions. The lead researcher was Dr. William Fenster, an agronomist who had published 17 papers on tillage systems between 1968 and 1976. Fenster's team installed monitoring equipment on 40 farms across Nebraska, Kansas, and Colorado. They measured rainfall intensity, soil loss per event, and residue cover percentage at the time of each storm. The study ran for 3 years. Fenster published the results in the Soil Science Society of America journal in January of 1981. The findings were precise. Fields with zero residue cover lost an average of 12 tons of soil per acre per year under typical rainfall patterns. Fields with 30% residue cover lost 4 tons per acre per year. Fields with 60% cover lost 1.2 tons per acre per year. The data was clear. More residue meant less erosion. The relationship was not linear. It followed a curve. Small increases in residue cover below 30% did almost nothing. Increases above 50% provided dramatic protection. Fenster's report recommended maintaining minimum residue levels through reduced tillage. Instead of moldboard plowing, use chisel plows that left residue on the surface. Instead of disking multiple times, disc once or not at all. The report included cost calculations. Reduced tillage saved 2.7 gallons of diesel per acre and 1 hour of labor per 40 acres. The savings were real but modest, $12 per acre at 1980 fuel prices. What Fenster's report did not address, and what no laboratory study could address, was how much residue was enough under field conditions. 30% cover was a percentage of surface area. A farmer standing in a field after harvest could not measure percentage cover without specialized equipment. The Extension Service provided cover charts, a laminated card with photographs showing what 30% looked like versus 50% versus 70%. Farmers were supposed to walk their fields, compare what they saw to the photographs, and adjust tillage intensity accordingly. The system assumed uniform residue distribution, consistent lighting conditions for visual comparison, and time to walk hundreds of acres making subjective assessments. It did not work. The erosion continued. May 1981, another major storm system. This time the damage hit hardest in Thomas County, Kansas. 16 farms reported significant soil loss. The worst was a section farmed by Robert and Catherine Voss. They had followed the Extension Service recommendations exactly. Chisel plowed instead of moldboard plowed, left stubble standing, reduced their tillage passes from 4 to 2. They estimated their residue cover at 35% based on the photo comparison method. The storm dropped 2.8 inches in 90 minutes. The field lost an average of 7 inches of topsoil across 80 acres. The erosion exposed the clay layer completely in the low areas. Robert Voss was 63 years old. He had inherited that farm from his father in 1959. The production loss from the eroded ground put them $14,000 behind on their operating loan. They sold the farm in 1983 for 62 cents on the dollar of its 1980 appraised value. The Voss failure was the one that changed the approach, not because it was the largest loss, because Robert Voss had documented everything. He had photographs of the field before and after the storm. He had kept his tillage records showing equipment used and number of passes. He had the Extension Service cover chart he had used to estimate residue percentage. He brought all of it to the County Soil Conservation Service office and asked a direct question: what did I do wrong? The agent who took the meeting was named Dennis Clock. He had worked for SCS for 11 years, all of it in Thomas County. Clock looked at the photographs and saw something the photo comparison method could not measure: residue distribution. The Voss field had residue, but it was not evenly distributed. The chisel plow had left strips of heavy residue between the shank paths and areas of almost bare soil directly in the shank paths. When Clock estimated cover percentage from the before photos, he got 35%, same as Voss. But the residue was concentrated. The bare strips were wide enough that water could build velocity before hitting the next residue patch. Once water is moving fast enough, residue does not slow it down. It just flows around the patches and keeps eroding. Clock wrote a summary of the Voss case and sent it to the state SCS office in Salina. He included one specific recommendation: stop measuring residue by percentage cover, start measuring it by depth. His reasoning was practical, not scientific. A farmer could not accurately estimate percentage cover, but any farmer could push a ruler into the residue mat and read a number. Depth was objective. Depth was fast to measure. And depth, Clock suspected, correlated better with actual erosion protection than cover percentage because depth indicated residue mass per unit area, not just surface coverage. The state office ignored the recommendation. Percentage cover was the established metric. Fenster's research used percentage cover. The USDA handbook referenced percentage cover. Changing the measurement standard would require revising training materials, recalibrating monitoring equipment, and admitting that the current approach was not working. None of that happened. What happened instead was that Dennis Clock started telling farmers in Thomas County to forget the photo charts and measure depth. He did not have research to back the recommendation. He had one failed field and a hypothesis. He told farmers to target 4 inches of residue depth after tillage. The number was not calculated. It was a guess based on what Clock had seen in the few fields that had not eroded during the May storm. Those fields had heavier residue. When he pushed a ruler into the mat in those fields, it measured between 4 and 5 inches. 6 farmers in Thomas County tried the depth method in fall of 1981. One of them was named Carl Traber. He farmed 900 acres of winter wheat northeast of Colby. Traber had lost soil in both the 1975 and 1981 storms. Not catastrophic losses, but enough to see yield decline in the eroded areas. He adjusted his tillage to leave 4 inches of residue depth and planted his wheat into that mat in October. The test came on June 9, 1982. The storm dropped 3.1 inches of rain in 2 hours across Thomas County. Traber's field did not move. He walked it the next morning expecting to find gullies. The ground was saturated but intact. No rills, no sediment deposits at the field edges. The residue mat had absorbed the raindrop impact and slowed the surface water enough that it infiltrated instead of running off. Traber measured the residue depth again after the storm. Still 3.8 inches, the rain had compressed it slightly but had not displaced it. 4 miles south, a field managed by Kenneth Staub using the conventional percentage cover method lost 6 inches of topsoil in the same storm. Staub had estimated his cover at 40% using the photo chart. His residue depth measured 1.7 inches. The difference in outcome was total. Traber's field yielded 52 bushels per acre that fall. Staub's eroded sections yielded 18. Traber told 11 other farmers what he had done. By fall of 1982, 23 farms in Thomas County were managing to a 4-inch residue depth target instead of a percentage cover target. The method spread farmer to farmer, not through extension meetings or official recommendations. It spread because it was simple enough to use and the results were visible within 1 season. The simplicity created its own problem. Farmers in other counties heard about the 4-inch target and assumed it was a universal recommendation. They adjusted their equipment to leave 4 inches of residue without understanding that the 4 inches had to be evenly distributed and that different crop types produced different residue structures. Wheat straw at 4 inches deep provided different protection than corn stalks at 4 inches deep. Wheat straw laid flat and interlocked. Corn stalks stood vertical and left gaps. In spring of 1983, a farmer named Gerald Ripp in Dundee County, Nebraska, managed his cornstalk residue to 4 inches depth and lost significant soil in a May storm. The corn stalks had been chopped by the combine, but the chopped pieces were large and they did not form a continuous mat. Water ran between the stalks. Ripp measured 4 inches depth at multiple points across the field before the storm. He measured the same depth after the storm. The residue was still there. It just had not stopped the erosion. Ripp concluded the depth method did not work and went back to moldboard plowing. He told the county extension agent that the Thomas County farmers were spreading bad information. The confusion reached the state SCS office by summer of 1983. 2 counties reported success with depth-based management. 3 counties reported failures. The agency needed to either validate the method or stop it from spreading. They assigned the investigation to an engineer named Richard Kressler who worked out of the SCS Plant Materials Center in Manhattan, Kansas. Kressler's job was to test seed varieties and residue management systems under controlled conditions. He was not a county agent, he was a researcher with access to rainfall simulators and measurement equipment. Kressler ran the tests in fall of 1983. He used wheat straw, grain sorghum stalks, and corn residue at depths ranging from 1 inch to 6 inches. He applied simulated rainfall at intensities matching the May 1981 and June 1982 storms. He measured soil loss under each combination. The results confirmed what Traber had observed in the field and what Ripp had discovered the hard way. Residue depth mattered, but only if the residue formed an interlocking mat. Wheat straw at 4 inches deep reduced soil loss by 92% compared to bare soil. Corn stalks at 4 inches deep reduced soil loss by 38%. The corn stalks needed to be chopped to lengths under 6 inches to form an effective mat. If chopped correctly, 4 inches of corn residue performed almost as well as 4 inches of wheat straw. Kressler published the findings in the SCS Technical Notes series in February of 1984. The report included photographs showing what effective 4-inch residue depth looked like for each crop type. It included equipment settings for combines and stalk choppers to produce the right residue structure. And it included one more critical finding that explained why the percentage cover method had failed. At 4 inches depth, wheat straw covered approximately 85% of the soil surface, but coverage was not the active mechanism. The mechanism was raindrop impact absorption and surface roughness. The residue did not have to cover every square inch. It had to break up the water flow and dissipate raindrop energy. 4 inches of properly distributed residue did that. 2 inches did not, even if it covered 60% of the surface. The data gave the depth method scientific backing, but it did not resolve the institutional problem. The USDA still based all its erosion control standards on percentage cover. Compliance monitoring for federal programs used cover percentage. Cost share payments for conservation tillage required minimum cover percentages. Changing those standards required approval at the federal level, which meant years of review and rulemaking. The standoff broke in a way nobody planned. In 1985, Congress passed the Food Security Act, which included the Conservation Reserve Program and a new compliance standard called sodbuster. Farmers who plowed highly erodible land without an approved conservation plan would lose eligibility for federal farm program payments. The law required SCS to write conservation plans for millions of acres within 2 years. The agency did not have enough staff to do percentage cover monitoring at that scale. They needed a measurement method that was fast, objective, and required minimal training. Dennis Clock, the county agent who had started the depth measurement approach in Thomas County, was by then working at the state SCS office. He proposed using residue depth as the compliance metric for the new conservation plans. The proposal went to the regional office in Lincoln, Nebraska in August of 1985. The regional conservationist, a man named Howard Schuman, approved it for use in Kansas and Nebraska on a provisional basis. The decision was administrative, not scientific. Schuman needed a way to process thousands of conservation plans quickly. Depth measurement was faster than percentage cover assessment. That was the entire justification. The provisional approval made depth measurement the de facto standard across the Central Great Plains by 1986. SCS agents carried rulers, not photo charts. Farmers managed to depth targets, not cover percentages. The technical basis came later, when the agency retroactively validated the method using Kressler's 1984 data and additional studies conducted between 1986 and 1988. The results were measurable within 3 years. The SCS monitoring stations that had tracked erosion rates since 1977 showed a regional decline in soil loss starting in 1986. Fields enrolled in conservation plans with depth-based residue standards averaged 2.1 tons per acre per year soil loss between 1986 and 1989. The same fields under conventional tillage had averaged 11.4 tons per acre per year between 1977 and 1985. The reduction was not total, but it was sufficient to drop erosion rates below the soil formation rate, which meant farms were no longer mining their topsoil. The 4-inch standard was not universal. Different soil types and different slopes required different depths. The final SCS technical guide, published in 1989, specified residue depth requirements ranging from 3 inches on flat ground with low erosion potential to 6 inches on sloping ground with high-intensity rainfall patterns. But 4 inches became the baseline recommendation for typical wheat ground in the Central Plains, and that number traces directly back to Dennis Clock pushing a ruler into the residue mat on Carl Traber's farm in 1981. The federal research establishment caught up slowly. The USDA Agricultural Research Service published a comprehensive study on residue depth and erosion control in 1991. The study involved 12 research stations across 7 states and confirmed what farmers had been practicing for a decade. Residue depth correlated more reliably with erosion protection than residue cover percentage, especially under high-intensity rainfall. The study quantified the relationship Kressler had identified in 1984. Each additional inch of residue depth reduced soil loss by 18% up to a depth of 5 inches. Beyond 5 inches, additional depth provided minimal additional benefit. By 1995, every state SCS office in the Great Plains had adopted depth-based residue management standards. The percentage cover metrics remained in some federal program regulations because the laws had not been rewritten, but field-level implementation used depth. The shift was complete, practical, and largely invisible outside the farming community. The modern no-till systems that dominate Great Plains agriculture still use the depth measurement. Planters are set to cut through 4 to 6 inches of residue depending on soil type. Yield monitors track production on fields with varying residue depths. And the data consistently shows that fields maintaining 4 inches or more of residue produce higher average yields over 10-year periods than fields with thinner residue, even when the thinner residue fields are fertilized more heavily. The yield advantage comes from moisture retention and erosion prevention, both of which compound over time. Carl Traber, the farmer who demonstrated the 4-inch method during the June 1982 storm, farmed his Thomas County ground until 2001. He sold the farm to a neighbor and retired at 73. He never patented anything or received formal recognition from the Soil Conservation Service. He did not attend industry conferences or publish articles. He measured residue depth with a wooden ruler he kept in his pickup, and he told other farmers what had worked on his place. Traber died in 2007. His obituary in the Colby Free Press did not mention erosion control or residue management. It listed his church membership and his surviving family. Dennis Clark retired from the Natural Resources Conservation Service, the successor agency to SCS, in 2003 after 34 years. He lives in Colby, Kansas. The residue depth measurement method is not credited to him in any official USDA publication. It is listed as a regionally developed practice that became standard through field validation. The wooden ruler Carl Traber used is not in a museum. It was not preserved. There is no plaque on his farm identifying it as the place where depth-based residue management was proven. The farm looks like every other wheat farm in Thomas County. The fields carry 4 to 5 inches of residue after harvest, same as they have since the mid-1980s. If you have farmed through the transition from moldboard plowing to no-till, or if you remember when soil loss was considered a normal part of grain production, leave a comment. Tell us where you farm and what you saw change. And if this kind of documentation matters to you, subscribe. These stories are not in the textbooks. They are in county extension files and retired farmers' memories. We are collecting them while we still can. The measurement of residue depth became so embedded in farming practice that most farmers who adopted it in the 1990s had no idea it originated from a single county agent's hypothesis and a farmer with a ruler. That erasure of origin is common in agriculture. The innovations that matter most are the ones that seem obvious in hindsight, the ones that get absorbed so completely into standard practice that nobody remembers they were ever controversial. But understanding how they became standard is important because it shows us something about how knowledge actually moves through agricultural systems. It does not move from research stations downward to farmers. It moves from observation upward to validation. A farmer notices something works. Other farmers test it. The practice spreads because it delivers results. Only after it is already widespread do researchers confirm what the farmers already know, and the institutions finally approve what they have been doing for years. This pattern repeats across almost every major farming innovation of the last 50 years. The institutions assume they lead. The data shows they follow. Raymond Kellerman, the farmer who lost his topsoil and his farm in that March 1982 storm, died in 1998. He never saw the widespread adoption of the conservation practices that would have saved his ground. He never knew that a farmer 4 miles away would conduct an experiment that would eventually protect millions of acres across the continent. His loss was real and permanent, but it created the urgency that made other farmers pay attention when they saw a different result. That is how agricultural change happens sometimes. Through failure documented carefully enough that others learn from it before their own failure becomes irreversible. If you want to understand agriculture as it actually exists, not as it is described in textbooks, keep watching. Subscribe so you do not miss the next story about how farming systems change when they do, and why some knowledge takes decades to become accepted even after the evidence is clear. Thank you for listening.